Thanks a lot, Derek, and thank you also for getting this all set up. The Design Infrastructure Alley, new to DAC, I think has been very successful, so well done on that. So we have heard a lot of presentations, and if this is your first one in the Design Infrastructure Alley, you're familiar with some of the messaging that some of the topics that we've been covering here in this pavilion. So thinking about like what ultimately should you get out of this presentation that's different from Google's or Amazon's or IC Manage's or anyone else's presentation is, there's a lot of great technology that's available out there for doing design on cloud, for doing hybrid implementations, et cetera. How do you wrap all of those great technologies up and actually deploy that out to your organization? How do you get out of POC hell, to excuse my language, and into kind of production, okay? And that's what this is really about. How do you orchestrate this and deploy this to an enterprise? So we talked a lot, and a lot of the presentations here have been about why cloud, right? So there's been a lot of discussion about why would an organization move their design to the cloud or integrate their cloud into their operations. We're not going to cover as much why. I thought we should go do a brief summary of why, but this presentation is going to focus more on how. How actually do I get this out to my organization and how I deploy it? But I think it's useful to step back and talk about the whys. We've heard a lot of them, but agility, so fast failure and fast success, being able to have the resources available where you're not sitting in queues, and so you can do more experimentation, you can expand the bounds of your design space, focusing on differentiating innovation. Is your organization great at infrastructure and operations for IT, or is your organization great at building semiconductors and design on chip? So also global infrastructure availability. So I'm trying to collaborate and support a global enterprise. How do I do that effectively and in a repeatable fashion? Flexible capacity planning, multiple consumption models. Sometimes I know that I can buy a 3-year reserved plan on the cloud. Sometimes I want very flexible usage patterns. How do I mix and match that to reflect my company's workloads? Specialization, I need specialized architecture for certain parts of my workloads, and the cloud offers that to me in an easy to obtain and ingest manner. And then the ability to collaborate, something that hasn't really come up in a lot of the discussions, but the cloud and SaaS delivery really enables an organization to collaborate amongst engineers and amongst the organization in ways that were previously more siloed, especially as we think about infrastructure commonly set up in like an on-premise environment. So that is the why cloud. But as we talk about how cloud and how to move an organization into the cloud, there are several challenges. And what I'm going to do is I'm going to lay out some of those challenges that in moving an organization to the cloud, and then both I'll address it from a Rescale perspective, and SixNines will also address how they manage some of those challenges. The first one is availability of applications and versioning. So there's a wide variety of applications organizations use to power their design. And Rescale works across a wide variety of industries, so we see a lot of different applications. But looking at all the applications and all the versions that your organization uses and all the scripting that you've built around all those different versions and all those different applications can be a big challenge to wrangle as an organization when you're moving to the cloud. And the second is governance. So unlimited cloud or unlimited resources does not mean unlimited spend, all right? And I think one of the things that is common as you're looking at cloud resources and this ability of having unlimited capacity is that there's a fear that this is going to mean unlimited spending. And the engineers are just going to run wild and they're going to use. How do I put some governance as an organization around the usage of the cloud? And then another challenge is end-to-end reliability and security. All of the major cloud providers have a shared security model. And by shared, it means as an organization, you have responsibilities too to provide those certain layers of security on top of your cloud implementation. So who's going to do that? for your organization. And as you look at the cloud, the infrastructure providers are going to take a certain amount of level of responsibility over their infrastructure. But it's still a matter of getting my data up into the cloud, encrypting that data, and managing the end-to-end process, understanding who's accessing it from an audit logs, from an identity and access management perspective. These are more challenges that as we look into the cloud that have to be addressed. And then running on the best suited architecture. There's a lot of architectures out there that are available, some very high memory, some low latency interconnect, and there's a variety of there's new and exciting architectures that all the infrastructure providers are debuting out. How do I match that right architecture with the right application for the right workload? And then accessing diverse data centers. We know that the data centers are out there, but how do I get the right data center to the right region in my organization and make sure that I'm talking within that region, that I'm using failover from availability zones, et cetera, and how do I deploy that out to an entire global organization? And then lastly, hybrid deployment. It's been a common topic that's come up, is that how do I leverage my on-premise investment, and then how do I use the cloud as an extension of my on-premise investment? And so some of those challenges are the ones we're going to be talking about. So as Derek mentioned, I am from Rescale, and I'm here with our partner SixNines, and we're going to talk about ways of tackling some of those challenges. So I thought I'd start with talking about a customer case study to kind of set the context. P-Semi, a Murata company, is a semiconductor company that's worked with Rescale, and they have deployed a select number of their workloads for their design process onto Rescale. And what they have done from a results perspective, that they've reduced some of their time to verify and test their front ends by over 10x. And they're doing this through essentially massive scale and the ability to parallelize a large amount of the designs that they are seeking to validate in a short amount of time. And this is it's a very peaky workload, all right? But ultimately what they had constrained assets, and it was taking over 7 days to complete a portion of their design cycle, and they brought that down to 1 day. And that kind of scalability and that flexibility enabled them to greatly improve their time to market. But moreover, they were able to deploy this to their organization without disrupting the flow of their engineering cycle. And the way that Rescale as a platform was able to fit into Peregrine Semiconductor, now P-Semi's organization, was non-disruptive to their overall design process. This is Rescale as a company. We were founded in 2011, so we've been doing cloud computing now for a little over 7 years. We are actually headquartered. Our headquarters office is about a block and a half from here, but we also have an office in London, Munich, Tokyo, Seoul, and Singapore. We do work with a variety of industries, and we are working with the semiconductor industry also. So what is Rescale? First of all, Rescale is a software company. So we develop a platform. And as you look at the platform, sorry about that, you look at really what is a platform, because that's an overused and cliche term now. But really what it is software, all the applications that you need to run your business, and then all of the underlying hardware and infrastructure that completes jobs, whether that infrastructure is on-premise or the cloud, and then integration of a bunch of workflows and management techniques. And this is really what the platform looks like when I start putting infrastructure and applications to it. So I have a bunch of different applications that are running my organization, and then I have some infrastructure that I want to be able to leverage, whether that's public cloud, on-premise compute, or private cloud. And so being able to bring this all together in one deployable, enterprise-ready platform is what Rescale has built. So what we're taking is a fully automated stack. When we look at on-premise compute, there's a lot of different technologies that go along when we're deploying an on-premise stack of technology. And what Rescale is doing that is delivering it through a SaaS platform. We are the only SaaS platform on the market to be able to deliver this type of technology. Furthermore, we have a global turnkey and IT HPC administration. and which means that you can manage roles, manage licenses, manage security, manage costs, and manage access. So all those shared responsibilities that we talked about is being done through the Rescale platform. There's many different deployment options for the platform. We could probably do an entire another session. A lot of our executives right now are in Europe, in ISC right now, talking about our hybrid methodology and talking about a few case studies that we recently deployed where Rescale platform can sit on top of or behind schedulers or in front of schedulers to deploy on-premise assets. So basically we're creating all the resources, whether they're on-premise or in the cloud, in a single platform that requires one workflow, one submission process, one API through and to access a wide variety of different types of resources. And then we have a global HPC infrastructure network. So wherever you see a black dot, we have a dedicated platform that is keeping data regionalized and also accessing resources that are closer to the end user. And lastly, we're built on the bedrock of security. So when we talk about all what is necessary and to maintain security and to protect IP of an organization, Rescale is doing that through a variety of methods that, because I'm out of time, I'm going to go ahead and turn it over to Eric. So I'd like to turn over our friends here at SixNines to talk a little bit about their portion of this journey. Yep, sorry about that. It's clicking forward automatically.
Okay. Thanks, Matt. So hi, I'm Eric Terrell, Managing Director at SixNines. A little bit about us. We've really been focused in the cloud for the last 10 years, really public cloud focused, so we've been working with AWS as a premier tier partner. There are about 35 premier partners in North America. We're really the only one that's focused on EDA and HPC. So we've helped lots of customers move to the cloud, and we also have offices around the US and in India. Our focus area is really high performance computing, and we have partnerships with Nice Software, which is now owned by Amazon Web Services. Really helps us, and sorry about that, we're clicking forward here. IC Manage, which helps on the filer side, has a pure cache tool that helps us accelerate our data transfer, having better smart data transfer to keep costs low. And then we can onboard tools like Ansys, Cadence, Synopsys, et cetera. We really have a foundation around DevOps automation. So the way we look at software-defined infrastructure, and when I say that I mean the cloud, is that we can automate all of our resources. We can govern those resources through automation. We can use that to secure the resources, and that way we don't let things slip through the cracks. We have repeatable processes, and that allows us to have both a more performant cloud, but also a secure, compliant cloud as well. We do also help our customers to focus on the right architecture for the right job. So we work on cloud architecture and migrations. And as Matt mentioned around some of the cost impacts of this, we have a service we refer to as Cloud CIO. And really that gives you more insight into what you're running in the cloud. And so we've worked with lots of customers to really get an understanding of, either it's by workload, by simulation, whatever, what the cost impacts are and how to manage that more effectively. So really what we do is we help you get answers faster, right? So we're not up here trying to talk about what CPU is faster, what GPU is better, but how we decrease turnaround times and enable you to get the answers faster, help you scale out compute, help you extend into the cloud, et cetera. So this is an example of what we're talking about here. So our customers are running thousands of cores in the cloud, anything from scalable GPU instances to instances with enhanced networking and using batch or cluster scheduling. Sorry about that. And some of the use cases, and again, they're similar workloads, but we focus on EDA and simulated performance, computational fluid dynamics, and we've also helped customers with audio simulations. But really what we can do is we can create a playbook, and we're using Ansible in this example. This is a configuration management tool to help script these environments. So with a push of a button or a single command from the command line interface, we can spin up compute clusters, and when we've spun through the job queue and those resources become idle, start turning them off automatically. And that's really a key to success with really any workload in the cloud, but especially EDA, right? Because we can, one of the advantages that we're talking about here is really being able to get access to capacity when we need that, and scale horizontally, adding nodes as we need to create a faster turnaround time for a job. But with that comes the responsibility to then make sure that those assets are turning off and they're not costing the company a lot of money. So here's an example of an HPC architecture in Amazon. And again, there's many ways to do this. There's also many tools available. And this is a good example of using the foundational software-defined infrastructure that Amazon provides to set up your virtual private cloud. So this is your software-defined infrastructure, your software-defined network. It's isolated to you. You control the CIDRs, the address space, the layout of the subnets, security, et cetera. This is all yours to control, right? And so in this case, we have a license server out in AWS and a secure subnet. We have an NFS share, and that's communicating with our scalable compute environment. So in this case, we have a compute optimized environment that we're spinning up. Again, our license servers could reside on premises, right? So that's an option here. There's lots of ways to design for this, to be able to take the same automation that we have for this, deploy this out into other regions in the Amazon infrastructure. And as I mentioned, using automation like we mentioned with Ansible. Amazon has a construct that's really their base unit of configuration called a CloudFormation template, and that's what's used to create and govern resources in AWS. So some of the optimization that we would go through on this, so we'd collaborate and design with you and make sure that we understand your workload, and again, you want to make sure that we're using the right tool for the job. So launch and configure these environments, test and optimize, and then tune, and then make sure we've got this documented so it's repeatable, right? Some of the things that you would want to consider here, storage is always a big consideration. So what some of us often say is, we have a compute problem in terms of capacity, but we're really solving that through storage optimization in a lot of ways. So in this example, we need to be able to place our storage close to our compute to make sure we have low latency. Our compute instances need to be typed correctly. So again, we've got an example of a compute optimized instance. There are memory optimized instances. There are general purpose. There are instances that support FPGA, any number of things out in the cloud that you can take advantage of. And again, networking and understanding where the workload is, where our users are, also being able to take advantage of remote desktop virtualization tools like DCV, which we run for customers in the cloud, allow us to access nodes that are close to our compute environment and be having to transition and transport pixels versus large amounts of data. So just some quick examples. Again, really what this is all about, with our customers and our partners, is how we can turn around results more quickly. Sorry about that. And sorry about that. So how do we turn that around more quickly? How do we have to not have to sit in a job queue for until our compute nodes are available, and we really have access to what we need when we need it. Yeah. And again, at the end of this, what we want to do is simplify this for you. So we're not claiming to be the experts of your environment, but what we've worked with and what we've implemented with our partners is a more simplified HPC EDA Foundation. How we spin up that the compute nodes, how we operate that and put this solution into your hands, and then make you not have to worry about life cycling, storage, snapshotting, things like that. And we do this by implementing our Cloud CIO solution. We tag resources so you can look at, any number of things on that environment. We help you with that. We set up a secure foundation. I think that's probably the most frequent, I'd say, non-EDA thing that we've talked about at this conference. So setting up that security out of the box so you know that if you're going to deploy this infrastructure, it's going to be in a hardened, secure environment. You'll be able to manage that, govern it, make sure that no one else can effectively pull data out of that environment or compromise your IP. And where this all fits in long term is, really one of the big benefits of the cloud is, using, say, object storage like S3 as your data lake and being able to pull information out of that to run your workloads, and then, starting to iterate on that. So now we're developing a foundation for a broader deep learning or other, data analysis, broader insight, AI, ML, et cetera, to be able to really take these EDA and HPC workloads to the next level. So thank you. I'm going to open it up for some Q&A. So invite Matt back up on stage. But Rescale and SixNines are partnering together. We're at booth 1236 down on the infrastructure alley on the right. So would encourage some questions and look forward to that. Questions?
So what kind of challenges do you guys see bringing the customer methodology onto the cloud? Because they have most customers have their own infrastructure that's already implemented. So what did you see bringing it over there?
So I guess I'll take the first cut at it. So really understanding the customer's methodology is really the first step in any of these processes to really understand what drives their requirements. And again, there may be a very mature process for hardware procurement and capacity planning, and that might go away. It doesn't mean, it might be different, it might not mean that it goes away, right? So how do we address that? Life cycling of resources changes. So we try to focus in on, what is the current way of doing things? What's the current mode of operations? Overlaying, a cloud methodology on top of that. So, how do we manage resources? A good example of, what we care about is really not necessarily avoiding failure, but recovering from failure, right? So, if we're launching a large cluster, and if we have one node fail, will that kill the whole, simulation, or can we recover from that? So those are some of the things to think about. I don't know if that answered your question, but I'll give Matt an opportunity to talk as well.
Yeah, I think we addressed some of them up front, but I would say one that we didn't touch on is, I think that's come up a lot, is high performance storage, right? So that continues to be a challenge with EDA workflows, and just the complexity of them, right? So how do we, a lot of custom scripting that is kind of built into the overall tool chain, right? And how do we package that up and get that into cloud efficiently? So I think that's another challenge.
I'll add one more thing to that. So, really, understanding, like how the workload differs. And if we could, maybe look at it, the construct a little bit differently, right? I may not have this exact configuration available, but that configuration can be tuned, or the placement of assets. We mentioned it a little bit here, but you can use things like placement groups to make sure that you, when you're launching resources like disk-based volumes, and compute nodes, that those are physically close to each other, and you have that control. So there's some of those things that out there that you want to think about.
Anyone else have any questions?
Let's get to the bar.
I did not say that. All right, well, let's everyone give them a big round of applause for their Thank you very much, guys.